Okay, hello everyone. We're going to be talking about the functions, general functions of the integumentary system, which involves our hair, skin, and nails. And today we talked about the three layers of skin: the epidermis, the dermis, and the hypodermis, also known as the subcutaneous layer. I have a picture of a tattoo here, just in reference to kind of what we're going to be talking about in the future. When we talk about the epidermis, that's the uppermost layer, and it is constantly being replaced. So when you get a tattoo, they have to make sure that we go down into the actual dermis, because that is something that doesn't get replaced constantly. So our general functions of the integumentary system are protection, body temperature regulation, cutaneous sensation, metabolic functions, blood reservoir, and excretion. So we're going to go through these step by step. First is protection. Your skin has an incredible ability to protect. There are three types of barriers that it's set up. The first is chemical. And the first way that this barrier is set up is through melanin. So melanin is produced in the epidermis, and it gives skin pigment. So this is the thing that makes our skin light or dark, and depending on where your ancestors are from, you're going to have lighter or darker skin. This melanin, as you can see, is produced by these melanocytes in the epidermis, and it's released in the skin. A buildup of this type of chemical protects DNA from UV radiation. So what it does is absorbs the light from the sun, the UV radiation, and it dissipates the energy as heat in your body. A second chemical barrier that we have is the low pH of our skin, which basically keeps the population of bacteria on our skin at bay. We have this other chemical here called human defensin. It is actually a natural antibiotic that literally punches holes in bacteria. And this last one here, I'm going to butcher the name, but it's cathelicidins. It is produced by a wounded skin to help prevent infection. We also have physical and mechanical barriers. The first is keratin. It's a protein that's produced by our skin, or that's found in great quantities in our skin, rather, and it's also in our hair and nails. It's a very stable, hard structure that prevents any penetration. Glycolipids are another physical chemical barrier, and these are nonpolar molecules that basically waterproof our skin. They're going to prevent any water-soluble substances from getting in. However, there are a lot of non-water-soluble substances or fat-soluble substances that can actually get in through our skin that these glycolipids don't defend against. Some of those things are oxygen and carbon dioxide, fat-soluble vitamins like A, D, E, and K, some poison oils like poison ivy and poison oak, heavy metals like lead and mercury, and some drug agents can still penetrate these glycolipids. So it's not a perfect barrier, but it does prevent a lot of foreign substances from getting in. The third type of barrier is a biological barrier, and the first type of this are the Langerhans cells. These are present in our skin, and they actually present antigens or foreign bodies to our white blood cells to help initiate the immune response. So if there's something foreign, called an antigen, okay, that's trying to cause infection or things like that, our body actually has to present that to a white blood cell so that it can start fighting it off. Another biological barrier, something that we've already talked about, is present in connective tissue, but those are macrophages. All right, those actually eat bacteria. And the last is DNA itself. So we talked about how melanin can defend against UV radiation, but DNA is actually a really great natural sunscreen. And what it does is it absorbs the UV radiation from the sun in the electrons in the DNA. Then that energy is transferred to the atomic nucleus, which causes that nucleus to start vibrating and moving quickly, which in turn produces heat. Then that heat is transferred to surrounding water molecules. So it takes something really dangerous, like UV radiation, absorbs it, dissipates it in our body, and then we're safe from it. Another function of the integumentary system is body temperature regulation. A normal body temperature is about 97.8 degrees Fahrenheit or 36 degrees Celsius. So when that temperature rises, remember we have that negative feedback loop that tries to bring that body temperature back down. So actually our blood vessels, our dermal blood vessels, will dilate and sweat glands begin to be stimulated, so then we start to sweat. And evaporation of our sweat dissipates body heat and it cools our body. On the other hand, when the environment is cold, these blood vessels constrict, and then our skin temperature, surface of our skin, that drops, and so passive heat loss, like we get when we're sweating from the body, that's slowed down because those blood vessels are constricted. The blood is not reaching the surface of the skin quite as easily. Next function is cutaneous sensation. We have cutaneous sensory receptors all throughout our skin. These are called exteroceptors. And basically what that means is they're going to respond to stimuli outside of the body. So we went over some of these structures today. We got through a lot of them actually. One we haven't talked about yet are these Meissner's corpuscles, and these are going to allow us to feel very light sensations, like a graze of the skin or the feeling of our clothes on our skin. These are things right at the surface. They're not deep. Pacinian corpuscle, or corpuscle, on the other hand, this is going to allow us to feel something that is deep. So pain, if we have a bump or a contact that's really deep, these Pacinian corpuscles are going to allow us to feel that. Then we have various nerve endings all throughout our skin, these yellow branching nerves here. These are going to allow us to sense pain in our dermis or epidermis. And then the hair follicle receptors, these not only allow us to feel, if our hair gets ripped out or whatnot, but it also allows us to feel, wind blowing through our hair. That hair is moving and we can sense that through those receptors. Another function of the integumentary system are some metabolic functions. So our skin is actually a producer or synthesizer of vitamin D precursor. So we need vitamin D in order to absorb calcium, and so we get this UVB radiation from the sun. You get two types from the sun. You get UVA and UVB. UVB is the good kind that helps you produce vitamin D. So we make this vitamin D precursor in our skin, which then goes to the liver to be processed, and further down to the kidney to be processed even more, where it's released as active vitamin D and can help our bodies absorb calcium. The other metabolic function the integumentary system has is the production of the protein collagenase, and it aids in the natural turnover of collagen, which is basically just a protein that deters our skin from getting wrinkly. Another function of the integumentary system is to act as a blood reservoir. So 5% of the body's entire blood volume is contained in the dermis, so our big section here. And we can see in this diagram that there are a lot of blood vessels going throughout the dermis. When other organs are in a need, if we're operating at a low blood volume for whatever reason, our nervous system can actually constrict these dermal blood vessels to provide more blood to the organs that are in need. Finally, the last function of the integumentary system is excretion. So most nitrogen-containing wastes are going to be eliminated in our urine. However, there are limited amounts that are going to be eliminated in our sweat. And if you've ever seen this sign at a pool, please shower before entering pool, what we are trying to wash off of our skin before we get into a pool are these nitrogen-containing wastes. And what happens is when you have a lot of nitrogen-containing waste combining with the byproducts of the filtration system in a pool, so like the chlorine, you form what are called trichloramines. And if you ever walk into a pool and you smell that chlorine smell, it's not actually chlorine that you're smelling, it's these trichloramines. And it's the chlorine byproduct combining with these nitrogen-containing compounds from our bodies. And it actually is really damaging to the upper respiratory tract. Because trichloramines are more dense than air, so they sit literally right on the surface of the pool, which is where you're breathing in when you're inside the pool. And over time, these can cause significant damage to our upper respiratory system and increase your risk for bronchitis and asthma and all those kinds of things. So as a swimmer, this was something that I was concerned about, and I actually researched when I was at KU. The other thing that is excreted in our sweat is water and sodium chloride, or salt. So this can be a significant source of loss of those two items. So we need to, if we're sweating a lot, make sure we're replenishing our water and our sodium chloride.